Welcome to the Cloudy Weather Office. It is May 10th, and this week we are expecting a heat wave to impact a generally large part of the United States, but especially the Great Lakes from Wisconsin, Illinois, Michigan, parts of Ohio and Indiana, even up into New York. This is the climate prediction forecast, and they help see temperature outlook as it says right here. And especially in northern Illinois, even parts of central Illinois, this entire area will likely see a heat wave, with California and more the west coast seeing a cooler kind of area of temperatures. And so here's why it's happening. First up, we need to go look at the temperatures. These are older models. It's the most available we have. And so moving into, this is about Sunday, so tomorrow. And you can see the area that we're watching is about over here, but then even extending out up into this area, we could see warmer temperatures. So Sunday, it's going to start cooler, but you can see it gets pretty warm. It gets into the 70s in Chicago, 66 in Michigan, so not super warm just yet. This forecast is for May 13th, which tomorrow is not May 13th. But then if we were to move into May 13th, which we are, you can see even on May 12th, 74 degrees in Chicago, 73 up there in Michigan. Super warm even, but that's about normal for Texas all the way up. It's not as normal up here. 90 degrees in the Dakotas, 80s here in Kansas and Nebraska. So it's going to be warm throughout the United States. But then the West Coast, you can see, is a little cooler. And then you can see our low temperature in Chicago, 60, Michigan, 58. So it's going to be relatively warm for lower temperatures. Gets up to 76 Tuesday, which is the start of our heat wave. At least 76 in Chicago. Little cooler in Michigan. But very warm. You can still see warm up here. So it's going to be pretty warm in Texas. Even 104 in southern Texas. Moving on. 79 Chicago, 73 in Michigan, 80 up there in Minnesota, 101 again in Texas, so very warm. And then, even then, we still hear Wisconsin, Chicago, Michigan, you can see relatively warm, cool, low temperatures. 87 in Chicago on Thursday, 80 degrees in Wisconsin, with 77 in Michigan, still really nice and warm. Again, 104 down in southern Texas, 92 in Florida. And it stays pretty warm, even throughout, and it stays really warm. Went back by accident. This is like 9 o'clock, 10 o'clock, 9, 10 o'clock Central Time. Still again, 75 in Chicago, 69 in Michigan, 65 up in Wisconsin. Very warm temperatures still. You can still see that the West isn't as cold or warm as expected. And then we start to cool off. We still see 79 in Chicago, 68, 66. You can see those 70s, 69 in New York. This is not New York City. But then we'll start to see a general cooling off. You can still see warmer temperatures. Again, 102 down south in Texas, 100 throughout much of Florida. But then as we go on, you can see we start cooling off in our main area where we were seeing warmer temperatures. We still see relatively warm temperatures in the south. Those aren't going to go away. But then part of this is we will see some severe weather coming in mostly down south, not really up north. So if we look at the 500 millibar winds, so these are lower jet streams, you can see we've got a low pressure system right there, right over Louisiana. That's gonna stay. But then you can see this trough, it's a dip in the jet stream, then a ridge. This is like high pressure, and then this is lower pressure. And then that dip continues, and it does go dipping further south. So we're not super concerned until about Sunday. Then you can see the winds just get all super messy when this dip moves in. So we're really focusing around now. This is 4 p.m. Sunday. There's low pressure here. You can see that dip. And there's more of a ridge up here signaling high pressure. So that could leave maybe a corridor from here to here. But then if we were to go again, this is now 7 p.m. Central Time. It's still relatively high pressure in this area. And if we went to the 250, because this shows the jet stream, you can see a good streak here, but even then continuing into that ridge, you can see that streak, which is something to maybe be concerned about. I would mostly be concerned if I were drawing the map here in this area, maybe not so far back into New Mexico and Arizona, but definitely Texas, Oklahoma, maybe stretching to parts of Illinois, but I don't think so because of that high pressure. And if we were to go into CAPE, which is convective available potential energy, that is the instability in the atmosphere, which is energy for storms. Anything above 1500 means that we're going to maybe see severe storms. You can see here, Oklahoma is above 3,500, and this is just on the surface layer. And even in that high pressure area, we're seeing relatively good numbers in the 2000s, so definitely enough for storms. Even down here in southern Kansas and western Missouri, we're seeing numbers as high as 4,300. But that's just surface based, so that's what's more on our surface. Mean layer kind of gives more of an average, and that it's a little lower, 3,000s, but still good for severe weather. Most unstable shows the most unstable, as it's kind of self-explanatory. Here you can see it kind of agrees with that surface based of a more major threat here. But even extending out into parts of Kentucky, Tennessee, as far south as Texas even, could see some severe weather. The supercell composite, this just helps give chances of tornadoes. And supercells, not all supercells form tornadoes, but you can see relatively high numbers. The supercell composite parameter, it is squishing together shear, which is kind of like the spin in the atmosphere, and then CAPE, and a bunch of other numbers to kind of give us chances. Generally, anything above 1 means severe supercells are possible. We're seeing 12 down here in southern Oklahoma. We're seeing good numbers even in this area. They're a little lower here, 1, so maybe not as high of a threat there. But I would definitely draw a few threat areas, maybe around here, around there, and we could see the Storm Prediction Center maybe surrounding it. Something like this, maybe. But it is far out. It says 00Z, that's 7 p.m. Central Time Sunday, because we are 5 hours ahead. But that being said, we don't know if these supercells would be hail, wind, or tornado, which is why we look at the mid-level lapse rates. They're decent. They're not the worst, so we could see some hail forming from these storms. Low-level wise, not much. So there could definitely be tornadoes. I'd watch out for that. The Storm Prediction Center sends out updates. I believe Sunday, so tomorrow, they could maybe have an update, but it's a little too far out to tell. All of this, it could change in 5 hours. It could all be different. Low-level lapse rates, which is temperature, how temperature changes, they're relatively low. So hail forms when we have positive and stronger lapse rates. We generally look for yellow, red. Green's okay. We could see some isolated hail. The lid strength, it is the cap, which is kind of a temperature inversion in the atmosphere. It takes some forcing to break through it. But looking at these numbers throughout the area, you're seeing negative numbers, which means the cap's super weak. Anything close to 0 means really weak. So there shouldn't be too much trouble for these storms to break through. The 0 to 3 kilometer SRH, it stands for Storm Relative Felicity, and that's also kind of the spin in the atmosphere. 0 to 3 is more supercell support. Maybe not so much in Arkansas, because you can see we have these lower numbers. I could see there being a threat in Oklahoma, Missouri, maybe Kansas. Up here, I'm thinking in Nebraska, it's going to be a glitch because they don't have very high numbers to support that. The HI is energy helicity. You can see that's a very strong amount right there, which is generally, we look for higher numbers. And surface temperature is there. It's very warm. It's in the 80s, 70s, 80s. Again, down south in Texas, almost 100 degrees. So definitely, those would support it. And dew point temperature would also signal us moisture. Usually we look for above 65, but with how high these temperatures would be, I'd look more 70. And you can see 70s all over, 74. So they've definitely got moisture to support storms if they form, which according to the simulated reflectivity, there's a chance here in Kansas and Missouri. Not really anything in Texas or Oklahoma. They could form though. There's definitely a chance. Our low-level jet is also something that we look for. It would allow for if it's coming from the Gulf, like some direction like this, let Gulf moisture come up, which I think is happening. And if we look at 925 millibars, so that's probably about less than a mile here above. Yeah, almost half a mile. You can see from these lines, it's coming straight up from the Gulf. So that would be sending a lot of Gulf moisture. We also look at the 850 millibar. We can't just look at 925. And again, you can see generally good agreement. It's coming up from the Gulf. Sometime maybe from here, sometime a little bit from Mexico even, but definitely something to watch out. And then this starts, the 700 millibar starts to form like our jet stream. Again, you can see low pressure around here, high pressure about right there, which is what we think could happen. Unfortunately, it's too far out to see Weather Prediction Center forecasts, because they only go out 7 days, and today is Saturday, so we can't see Sunday's forecasts. So it's a little too early to say too much. Something to watch, but always something to watch in this time of the year. May through June, we could see tornadoes throughout this area, and that's common. That's very common. With all the low pressure systems and our El Nino, which is actually, it's neutral right now, so we're not El Nino or La Nina. Thank you for watching. We'll be back next week with more, probably next Saturday, so subscribe if you want to learn more. We'll probably talk about the heat wave, the end of that, because it's supposed to end this weekend. Well, next weekend. Thanks for watching.